All right, Chapter 2, Section 7, Changes in Matter. We're going to talk about physical and properties and physical changes. Talk about chemical properties, chemical changes, as well as energy, types of energy, and we're really going to look at density. So first, let's talk about physical properties. A physical property is a property that can be observed without changing the identity of a substance. This includes the melting and boiling points, the color of something, the brittleness, which is how easily it is for something to snap and break, malleability, how easy it is to bend something, to flatten something. This is usually true in metals. Mass and density. Again, density is the most important one, which we're going to talk about more in depth here very shortly. A physical change is a change in a substance, but it doesn't change the chemical composition. So again, it changes the form, but not the actual substance. So, for example, cutting, or you can think of that as ripping. If you start with a piece of paper and you cut the paper in half, if you rip a piece of paper in half, even though you ripped it in half, it's still paper. You started with paper, now you ended with two smaller pieces of paper. It's still paper though. Boiling, freezing, and melting are actually physical changes. Take the example of water. If you have ice, what is ice? Ice is H2O. It's just a solid form of water. If you melt ice, it turns into a liquid. What's that liquid? It's still H2O. If you freeze that liquid, it changes back to ice. It's H2O. If you take that liquid water and boil it and turn it into steam, guess what that steam is? Yes, it's H2O. It's still water. You started with water, you ended with water. If you do condensation, if you condense from a gas to a liquid, it's still water. Okay, so boiling, freezing, and melting, those are physical changes. The most difficult one that people have trouble with is dissolving. So if you take salt and dissolve it in water, okay, even though it looks like the salt disappears, it doesn't. That is a physical change because you can get that salt back very easily. You just boil off the water. Same thing if you pour sugar in water. That is, whenever things dissolve, that is a physical change. Physical change. The most important physical property is density that we're going to talk about. We're actually going to have a lab. Our second lab from Sinclair is about density. Density is the mass per unit volume. It's an equation basically, and it says density equals mass divided by volume. This little crazy symbol here, which is the Greek lowercase letter rho, that means density. So density equals mass, that's what the M is, divided by volume. The standard units for density are kilograms per meter cubed. However, in chemistry, we don't usually use kilograms and meters. We'll use grams per centimeters cubed, or more often sometimes, well, I say more often than sometimes, a lot of times we'll also use grams per milliliter. So again, density is grams per milliliter or grams per centimeter cubed. Now, let's look at this equation a little bit more in depth. If we increase the mass, if we increase the numerator and keep the denominator, keep the volume constant, what happens to density? Well, anyone who knows anything about math, especially fractions, knows that if you keep the numerator, if you increase the numerator while keeping the denominator constant, your answer is going to go up. So that shows us that density and mass are directly related. Sometimes we call that directly proportional. So whatever you do to mass, you do the exact same thing to density, so long as volume remains constant. So if I double the mass, I'll double the density. If I take half the mass away, the density will go down by a half. Now, what happens if we keep the denominator, what if we change the denominator by increasing the denominator and keeping the numerator constant? Well, again, if you know anything about math, you know that if the numerator is constant and your denominator gets bigger, you have a larger denominator, your answer is going to be smaller. So what that shows us is volume and density are inversely proportional. If volume goes up, density will decrease, go down. If volume goes down, density increases, assuming mass remains constant. Substances that are more dense than others will sink, for the lack of a better word, downward. For example, water has the density of 1 gram per milliliter. Now, let's take 2 pieces of wood. One piece of wood has a density of 0.7 grams per centimeter cubed, just to change up the units. If I put that piece of wood in water, it will float because it's less dense than water. But if I take another piece of wood that has a density of 1.7, since it's greater than 1, it would sink. And I meant to say 1.7 grams per milliliter. You gotta make sure you say your units. So again, substances that have a higher density will settle lower down. Substances that have a smaller density will settle up higher. All right, chemical properties and chemical changes. A chemical property is a property that is observable in a chemical reaction, and it changes in the identity of one or more reactants. For example, flammability. How flammable is something? Everyone's like, let's set something on fire. Yeah, but can it even be set on fire in the first place? Maybe it can very easily. Maybe it takes a little bit. Maybe it can't at all. Oxidation states, we'll talk about more about that a little bit later. Toxicity, how poisonous something is. Reactivity, how quickly does a substance react with something else? Those are all chemical properties. A chemical change is when you start with one substance and then you create a totally different substance. Signs of these chemical changes include heat being produced, which is called exothermic, or heat being absorbed, which is called endothermic. There can also be a color change, and there can be gas production. There's another one where if you put 2 liquids together, you can form a precipitate, which means you take 2 liquids and you form a solid. Another example is if you take 2 chemicals and it starts to illuminate, like a glow stick. That's another sign. But again, be careful. These are not automatic. If you see these, that does not automatically mean there's a chemical change. For example, if you take a piece of paper and then draw on it with a crayon, yeah, that's a color change. The paper went from one color to whatever the color of the crayon is. That is a color change, but that's not a chemical change. That was a physical change. So again, be a little careful with figuring out whether or not something is definitely a sign for a chemical change. But just another example of a chemical change from going from one substance to another is, think of a match. A match is an organic carbon structure. Okay, it has carbon, hydrogen, all sorts of different elements. But once you burn it, it turns into a pure black substance. That substance is pure carbon. So it went from a crazy carbon complex structure with carbons, hydrogens, oxygen, probably nitrogens in there, all these other elements, and then just plain carbon. So it went from one substance to another substance. That's a chemical change. Types of energy. Again, you don't really need to know too much about energy. We're going to go through this really quick. Just know that energy is the ability to do work, which means to cause a change. Whenever something goes from one thing to something else, whenever you move, whenever there's a change in anything, just know that that requires energy. For example, if you are laying in bed and you need to go to the toilet, the fact that you changed from your bed to the toilet, that required energy for you to get up and move. When it comes out of your bowels, that required a change. It was in your belly, now it's somewhere in the sewers. That took energy to do. Sometimes it takes a lot of energy to do that. The 2 most common types of energy are potential energy, which is stored up energy, either due to position or it's due to chemical bonds. But if we talk about the position one first, which is known as gravitational potential energy, think of someone on a high dive versus a low dive. If 2 people do a cannonball off a diving board, the person on the high dive will make a bigger splash. The reason why is because they're higher off the ground, which gives them more stored up energy than someone who is closer to the water's surface. When we use these stored up energies, when the stored up energy is released, then it changes into kinetic energy, which is energy in motion. It's energy that's being used. And that's all you really need to know about types of energy. And that's it for Chapter 2, Part 7.